In this video, we're going to talk about the grouping and folding features of PerfVIew. And to start off, we're going to again use that same data that we've been using of CPU stacks that were collected on the tutorial example. And this would be our default view. This I have already resolved a whole bunch of symbols in previous runs of PerfVIew, and so lots of DLLs have already been looked up, although you can see that some of them have not. And what I want to do to show you what's going on with folding and grouping is to first just turn it all off. And the grouping feature is controlled by this group paths dialog box, and the folding feature is at least partially controlled by this fold %. So I'm going to clear both of those, and this gives me a view of what the display would look like if grouping and folding weren't on. And what I'm also going to do is I'm going to expand, and I've also gone to the call tree view, and in the call tree view I'm going to expand all of the nodes. And the first thing you're going to notice is that there are quite a number of them. Like, there are lots and lots of call tree nodes in here. And so you can imagine that it gets a little complicated. And keep in mind, this particular program, in fact, let's go ahead and do an Alt-D and open it up. And it is a very, very simple program where the main program calls these recspin and recspin helpers, which then calls spin for a second, which then just calls date time now in a loop, in this loop, for 5 seconds. So it's a very, very simple scenario from a programming point of view. And what we'd really like is we'd like it to tell us very quickly that datetime now is the hot function that we're working on. And the problem is that if you look in all this, it's actually kind of hard to see that. And the reason is because there's lots of stuff here that we sort of don't care about. So, for example, keep in mind that what we see when we look at a call tree view is literally the stack where samples were taken. So, in fact, from the root, we were in process, which did a thread, which then called DLL RTL user thread start, which called some routines in here, which called into the CLR, which called into finally into our main program, which then calls recspin and recspin helper, which then call datetime now, and then they calls into a bunch of helper functions in here, which then finally calls into the CLR to do a multiplication, and then these go bopping back and forth, up and down. And you can sort of see that while that's all true, it's also sort of irrelevant. We really want to say there are things that we care about and there are things that we don't care about. And that is what grouping and folding is all about. And I'm going to start with folding because it's easier to explain. What folding does is if I put 1% in here, or a 1, which basically means 1%, notice, actually, let's go back for a second. Notice how big the bar is here, and then when I make it 1, it got bigger. So a bunch of nodes went away. Which nodes went away? What folding does is it says this. I don't care about any routine that consumes less than, in this case, 1% of the total CPU that's being consumed. So basically, anything that consumes less than 50 milliseconds, because I have a 5-second total time, anything that uses less than 50 milliseconds over the whole trace, I don't want to see that detail. That detail is not interesting to me. It's too small to catch my notice. And so I want you to fold it into whoever called that function. So when you turn folding on, it doesn't actually ever change the numbers of any of the it never changes the total count, but it will remove some nodes, the small ones, and it will fold them into whatever's left. And so, in fact, I could make this number pretty big, and even more nodes will go away. And you can see now that quite a few are removed. But it's still the case that I have lots of goo that I sort of don't care about. All this goo inside of the CLR I probably don't care about. I do care about the tutorial example itself. I care about my code. And so in fact, the default, and this is where grouping helps a lot. So folding helps get rid of all the little tiny detail, the irrelevant ones. And what it effectively does is inline them into their parent, or the person who called them. But what grouping does is it segregates the world into things that I care about and things that I don't care about. And in fact, you can see actually that there's actually a very powerful search and substitute convention going on here that I'm not going to explain in this video. But you can see that there are some that are given names. So you can see just my app, grouped by CLR OS entries, grouped by modules, and so forth. And these take you quite a distance. So realistically, you could just use these and you'd be in pretty good shape. And I'm going to pick this one that is on by default called Just My App. And what Just My App does is that it segregates the world into your app, which is defined to be the exe and any DLLs that are next to the exe that are in the same directory. If you're in the app, I want complete detail. I want to see everything. And so because main called recspin and recspin helper and so forth, I see all of that detail. Everything else, however, I don't see. And you can see that all of those methods that used to be between the thread and main have been collapsed down into one method called other. And then the other is the group. So everything that's my app is not grouped, and everything else is grouped into this thing called other. And moreover, it's a special kind of group. It's what's called an entry point group. And an entry point group remembers how you entered the group, but then as long as you stay inside that group, it doesn't show you any detail. It folds that away. So in the case when the thread called this NT start point, it pops out. It stayed inside the non-app code for a while. In fact, it went through a bunch of DLLs in the CLR, and finally it popped out into app code, at which point it shows you the complete detail. And then I'm going to expand all here, and those in turn call a bunch of routines, and then it leaves the app code when it called an mscorelib function, which isn't in the app, right? It's not in that directory. And it happens to call datetime now. And then a whole bunch of other things happen. Calls the CLR to do adds and subtracts, and you might call operating system functions and so on. But you don't see that, and you don't really care about it. All you care about is that I called a foreign routine called datetime now. And see, notice how nice that is with respect to the source code. It showed me that I had all the detail inside my source code, because this is source code for those app exe in this case. And then whenever I call out to things that aren't my app, like this datetime now, then I don't see those. And that's what grouping does. If I turn off folding, you'll actually see a few more things, because I actually don't call just datetime now. I also happen to call the constructor to datetime and UTC now, and I call some other things from my program directly. Keep in mind that I don't see everything that I call, because if it doesn't consume enough CPU time, I won't see it. It has to show up as one of the samples in my 1 millisecond CPU samples. But you see, these tiny ones that only consume one sample here and one sample there, they're probably not that interesting to me. So in fact, the default is group by just my code, and then fold away anything that's less than 1%. And between the two of those, they work in tandem, produce a very nice, display of what's going on. And if you go back to the by function or the by name view, you get really what we were looking for, is that, which is that 87.6% of all my time is being spent in datetime now. So there are other useful groupings that you'll probably want. If you don't like just my app, and sometimes it doesn't work. If the host, some other exe is the host for your code, just my app is probably not doing the right thing, because it's hiding your code and showing you app code, which is not interesting because it's the host. It's not the part of code that you're interested in. When that happens, usually a good one to choose is this one called Group Module Entries. And what that one does is it treats every DLL as its own little group. So you can see that MS Core Lib has become a group, and we entered that via datetime now. But then that one in turn actually will call the CLR, which is a different DLL, and therefore a different group in this grouping. And so you get to see all of those details. So anytime you hop into a DLL, you'll see how you hopped into that DLL, but then you won't see any detail as long as you stay within that DLL. And again, you get actually a pretty nice view this way too. So I'm going to do an expand all here, and you can see that NTDLL called MS Core EE, which called MS Core EI, called the CLR, and it turns out there were lots of CLR functions inside there when it finally calls tutorial. Notice also that there is the grouping in some ways is now a disadvantage here, which is that all of my functions inside the tutorial applications are gone. Like they're all I know is that I entered main and then I leave by doing datetime now. That's probably not what I want. And so there's ways of selectively turning off the grouping. And one of the most important is this one. You go to grouping and ungroup module. When you ungroup a module, what you're saying is that whatever module I'm currently selected, and in this case I've selected the tutorial module, don't show me. I want full detail for that for any function in that module. So when I do that, I get back something that actually looks a lot more like just my code. All of the functions within just this DLL are shown in full fidelity. But then when that one in turn calls into something that's not in tutorial, I go back to my other grouping, and in this case it was grouped by DLL, so it shows me the grouping into MS Core Lib and then in the CLR, and as long as the CLR doesn't call something else, but like here the CLR called something else, it called into NTDLL, so I see that level of detail. So you can see that grouping is quite powerful because I can sort of take lots and lots of functions that have large amounts of irrelevant detail and collapse it down into something understandable, and then I can selectively ungroup what's important to me. And that technique is quite valuable. And that concludes this quick talk on grouping.